Hello, everyone. In this week's lecture, we talked about normal distribution. And as you know, the normal distribution is the most important distribution in statistics. Although it probably not that important in this class, but I still want to show you why it's important. In the class, I mentioned central limit theorem. Basically is when you have random variable independently distribute, and if you sum all the random variable together, and they will be pretty much follow normal distribution. And I want to show you by a simulation, which I just create in the Excel spreadsheet, and you can see under what condition that those summation will become more and more normal, okay? Let me share my screen. All right, okay. See, here basically I simulate some random number, okay? As you see, those random number are uniformly distributed from 0 to 1, okay? I simulate 20 random numbers, okay? And in this column, I sum the first 3 random numbers together. And in this column, I sum all the 20 random number together, okay? And I have this simulation run 200 times. So I have the summation, okay, of 200 rows, okay, and for each of these 2 columns. Then I made the histogram, okay, for this column, okay, it should be the sum of 3 random variable, okay, and then made the summation histogram of this random column, okay, so it's the sum of 20 random variables, okay, and you can see that the summation become more and more normally distributed, okay, from the histogram. When you have those independent random variable, when you have a large number of those independent random variable, okay, sum together, okay. So although each random variable is uniformly distributed, but their summation become more and more normally distributed, okay, when you have more random variable summed together, okay. And I also want to show you a device which is called Quincunx, all right, and it also demonstrates normal distribution. Let me. All right, so what's this device? Well, basically, it has a funnel here and a drop ball, okay? And here are all the pins. And when the ball drop, if there's no pins, the ball will drop straight over here to this pin, right? And but if there's a pin here and it just bump the ball into random direction, okay, and then over all those layers, eventually the ball will drop to one of those pins. And we count, how many balls in each bin, okay. All right, so after drawing over 5,000 balls, we can see that the distribution of ball in each bin become pretty much normal distribution, all right? So how to understand this device is like at each bump, okay, you're adding a random arrow on the dropping path of the ball. And over all those layers, you are adding, small random arrow, many small random arrow. Okay, it's like adding our, you know, previously we add 20 random number, right? And add all of them together, and eventually it become a normal distribution. All right, so I put the link of this website on Canvas. So you can go there and click the link and play around with this device. All right. One more thing, normal distribution is also very good for approximate some other distribution. Okay, in the textbook, there's a session taught about normal distribution approximation to binomial or Poisson distribution. Uh, and you can see, many times when you calculate binomial or Poisson, the formula is kind of difficult, but use normal distribution is a little bit easier to calculate the probability of calculate the either PDF or CDF. Okay. All right. So under what condition the binomial distribution can be approximated by normal distribution? There's actually animation here, okay, provided by the textbook, okay, and you can see that try different number for the probability, let's say 10, and n equal to 50, that's for binomial distribution. And to see the histogram, in this case, the normal is, still okay. But if I reduce normal to 10, reduce n to 10 and reduce p to 1%, okay, and you can see that the distribution is very skewed, and normal in this case is not a good approximation. Play around with those numbers, and you can see, under what condition that a normal distribution can be a good approximation of a binomial distribution. All right, that's pretty much for this additional information for you, and for you to better understand normal distribution. In next week, we are going to talk about other continuous distribution that are not normal. We already started exponential distribution, and then we'll extend the exponential to Erlang distribution, gamma distribution, Weibull distribution, and log normal distribution has a relationship and another relationship with normal distribution. And we'll talk about beta distribution and finally the triangle distribution. All right, I will see you on Tuesday.